Myself, I'm Ganga Bhavani from EC Department, Assistant Professor in EC Department. So, today we'll discuss about the topic different coupling schemes used in amplifiers. We'll just see what are the various coupling schemes used in amplifiers. So, before that, we'll just see what is a multi-stage amplifier actually. Okay. So, in general, the output that you're getting from single stage amplifier, it's not sufficient, or you can say that it is insufficient, whether it could be a voltage amplifier or power amplifier. So, to get a sufficient output voltage, we make use of multi-stage amplifiers. So, usually single stage amplifiers are replaced by multi-stage amplifiers. Okay. So, a transistor circuit containing more than one stage of amplification is known as multi-stage transistor amplifier. So, a transistor circuit which contains more than one stage of amplification, it's called as multi-stage amplifier. So, in multi-stage amplifiers, what is usually done is output of first stage is coupled to the input of next stage. Okay, using a coupling device. By means of a coupling device, the output of the first stage is connected to the, or you can say it is coupled to the input of the second stage. And similarly, the output of second stage is coupled to the input of third stage. Like this, the coupling from output of one stage to the input of next stage will continue. So, these coupling devices, by means of what you are going to couple is by means of a capacitor or a transformer. So, this process of joining two amplifier stages using a coupling device is called as cascading. Okay. So, coupling is nothing but the method of combining, or the means used to combine the output of first stage to the input of second stage. And cascading is nothing but the process of joining two amplifier stages using a coupling device is called as cascading. So, if you look at this figure, it shows a two-stage amplifier, okay, connected in cascade. So, the output of first stage is connected to input of second stage by means of a coupling device. So, coupling device here is connected between output of first stage and input of second stage. So, overall this is a two-stage amplifier, okay. The input is taken to be Vi and output is V0. Now, the overall gain of this two-stage amplifier is nothing but product of the individual stages. Suppose let us assume that the gain of the first stage is AV1 and the gain of the second stage is AV2. Then the overall gain of this two-stage amplifier will be AV1 into AV2. So, what is AV1? V2 by V1. That is, output of first stage is taken as V2, V2 by V1 into V0 by V2. Okay. So, if we say this is input is V1, okay, and here you have V2, okay, and the same V2 is given to second stage, and this is V0. So, the first stage gain is what? V2 by V1, and the second stage's gain is V0 by V2. So, on the whole, you will get total gain AV equal to AV1 into AV2, that is nothing but V0 by V1. Okay, V0 by V1. So, the overall gain of a multi-stage amplifier is nothing but product of the gains of individual stages. Okay. So, here AV is overall gain, AV1 is voltage gain of first stage and AV2 is voltage gain of second stage. Now, like this, if there are n number of stages, then product of voltage gains of those n stages will be the overall gain of the multi-stage amplifier circuit. So, in that case, what will be AV equal to AV1, AV2, AV3, AV4, so on up to AVN. Product of all these individual stages, gains of the individual stages will be equal to the overall gain of the multi-stage amplifier. Now, why you need coupling actually? Why you are making use of a coupling device? Or simply to say, what is the purpose of coupling? Okay. So, the purpose of coupling device is to transfer AC output of one stage to the input of next stage. So, first thing is to transfer the AC output of one stage to the input of the next stage. And second main thing is to isolate the DC conditions of one stage from the next stage. Okay. Two main reasons or two purposes of coupling. The first one is to transfer AC output of one stage to input of the next stage. And second one is to isolate the DC conditions of one stage from the next stage. Okay, so this is the main reason why you're making use of coupling. Then, what are the different types of coupling you have? Now, if you look at this figure, which is a 3-stage amplifier, okay, each stage consists of one transistor. Okay, in each stage you will be having one transistor and the associated circuit. That is whatever circuit you have for that particular amplifier, you'll be having that circuit. And at each stage now, it is coupled to the next stage through a coupling device. You can see here, you have coupling. Okay, so by making use of a coupling device, the output of one stage is connected to the input of second stage. So, as you can see, there are 3 types of coupling: RC coupling, transformer coupling, and direct coupling. So, based on the type of coupling used, you are giving the amplifier also the name based on the coupling used. If you look at this figure, you can see that there are you have different types of coupling. Which type of coupling you are using? It could be either RC coupling, transformer coupling, or direct coupling. So, accordingly, the name of the multi-stage amplifier will be, if it is RC coupling, it is RC coupled amplifier. If it is transformer coupling, you are naming it as transformer coupled amplifier. Or if it is a direct coupling used, then it is called as direct coupled amplifier. Okay. So, there are 3 types of coupling: RC coupling, transformer coupling, and direct coupling. We'll just see each one in detail. Okay. So, RC coupling. This is the most widely used method of coupling, formed using simple resistor-capacitor combination. So, in RC coupling, to achieve coupling between the first stage and the next stage, you'll be making use of simple resistor-capacitor combination. Okay. So, the coupling networks using this coupling are called as RC coupled amplifiers. So, in a multi-stage amplifier, or it could be 2-stage or 3-stage, that uses RC coupling, it is called as RC coupled amplifier. So, the capacitor which allows AC and blocks DC is the main coupling element used here. Okay. So, if you are making use of, you can see in this figure. See, this is the first stage. Up to here, it is a first stage. Okay, this is a first stage and this is a second stage. So, this first stage is connected to the second stage. The output of first stage is connected to the second stage through this resistor capacitor combination. Okay, basically you can see here coupling capacitor CC. Okay, and RC of the first stage. So, this coupling network consists of one resistor RC and the one capacitor CC, which is connected between the 2 stages. Okay. So, the coupling capacitor passes, so this coupling capacitor CC, it passes the AC from output of one stage to the input of next stage, while blocking the DC components from DC bias voltages to affect the next stage. It allows the AC component from one stage to the next stage, and at the same time, it blocks the DC components from DC bias voltages to affect the next stage. Okay, so basically the coupling device used in RC coupling is nothing but a simple resistance capacitance combination, RC and CC. Okay, so this is about RC coupling. Next we'll see about transformer coupling. So the coupling method that uses, as the name itself suggests, we can understand that the coupling method uses transformer as a coupling device. Okay, so such type of coupling is called as transformer coupling, and here you are not going to use any capacitor. Okay, and because the transformer itself will convey the AC component directly to the base of the second stage. Here you are not going to use any capacitor, simply only one transformer will be sufficient, and this transformer itself will convey the AC component directly to the base of second stage. Okay, so the secondary winding of the transformer provides a base return path, and hence there is no need of base resistance also. So in transformer coupling amplifier, you don't need a base resistance also, because the secondary winding itself will provide a base return path. Okay, so this coupling is popular for its efficiency and its impedance matching, and hence it is mostly used. So compared to RC coupled amplifier, transformer coupled amplifier is mostly used. You can see from this circuit also. See here, this is first stage of the amplifier. Okay, and this is the second stage. Now between this first and second stages, that is output of the second stage, first stage is connected to input of the second stage through a transformer. Okay, so this is called as coupling transformer. You can see this is primary winding and this is secondary winding. So the output of the first stage is connected to input of the second stage by making use of a coupling transformer. And the output here is measured again using a output transformer. Okay. So direct coupling. Third type of coupling is called as direct coupling. If the previous amplifier stage is connected to the next amplifier stage directly, as the name suggests, direct coupling, here you are not making use of any coupling device. Directly the output of first stage is connected to the input of second stage. The individual amplifier stage bias conditions are so designed that the stages can be directly connected without DC isolation. Okay, so individual amplifier stage bias conditions are designed such that the stages can be directly coupled, okay, without any DC isolation. So simply to say it is direct coupling means you are not making use of any coupling device. Simply directly the output of first stage is connected to the input of second stage. So the direct coupling method is mostly used when the load is connected in series with the output terminal of the device. Okay. So this direct coupling method is mainly used when the load is connected in series with the output terminal of the active circuit element. Okay. For example, in case of headphones, loudspeakers, etc. All these are examples where direct coupling method is used. You can look at the figure. Okay. So here you can see a 3-stage amplifier where you have stage 1, stage 2 and stage 3. Output of stage 1 is connected to input of stage 2 directly. That is, you can see this direct connection. Here you're not making use of any coupling device. And even here also you are giving it directly without making use of any coupling device. So this is about direct coupling. Okay. So we'll just see what is the role of capacitors in amplifiers. We have come across many capacitors here so far. So if you see in all the circuits, you have seen you have a right from beginning. If we start, you can see here Cin input capacitance and then Cc coupling capacitance. This is Cin input capacitance. Cc is coupling capacitance, and you have Ce. Okay, Ce in parallel, connected in parallel with Re. Ce is generally called as bypass capacitance. Okay, so we'll just see in detail what is the role of all these capacitances: Cin, Cc, and Ce. Okay, so other than coupling purpose, as you see, Cc is as we have seen, Cc is mainly used for coupling purpose. Okay, but still, other than the coupling purposes, there are other reasons for which few capacitors are being used in the amplifiers. So let us know about the role of capacitors in amplifiers. First thing, I have seen Cn. Where is Cn connected? Between the AC source and the input of the first stage. So input capacitor Cn, it is present at the initial stage of the amplifier. Okay, that is after AC connecting the AC signal. So what this Cin does, it actually couples the AC signal to the base of the transistor. Okay, so to have a rough figure, it is something like this. Suppose if this is Vin AC signal, then you will make use of a capacitance Cn here. Okay, so you are making use of capacitance Cn in order to connect the AC input voltage to base of the first stage. Okay, so the capacitor Cn, if it is not present, what will happen is the signal source will be in parallel to the resistance R2. R2 usually you will have this resistor circuit here, R1 and R2. R1 and R2. Okay, so if Cn is not connected, what will happen in such case? This signal source will be in parallel with the resistance R2. Okay, and so as a result, when the signal source will be in parallel with R2, this will affect the biasing conditions. This will affect the biasing conditions. So the bias voltage of the transistor base, so whatever the biasing voltage applied to the base, it will be changed. So Cin allows the AC signal from source to flow into input circuit without affecting the biasing conditions. Okay. So the main reason why you're connecting CN is, first thing, in order to connect between, it is used to connect the AC voltage to base of the transistor, first stage of the transistor. And if you are not connecting CN, usually this R2 will be in parallel with the source. Okay. So as a result, what will happen? So the signal source will be in parallel to R2. So as a result, the base voltage applied to the transistor base will be changing. So CN allows AC signal from source to flow into input circuit without affecting the biasing conditions. So this is the main use of the input capacitor CN. CN is called as input capacitor. The next one, emitter bypass capacitor CE. The emitter bypass capacitor CE is connected in parallel to the emitter resistor. If we have seen in the figures, previous different types of coupling, I have shown here. Yeah, see here. RE, this emitter bypass capacitor CE is connected in series with RE. Sorry, in parallel with RE. So CE is connected in parallel with RE. So this is called as emitter bypass capacitor. It is connected in parallel with emitter resistor RE. So it offers a low reactance path to the amplifier AC signal. The main reason why you are connecting this capacitance CE in parallel to emitter resistor RE is because it will offer low reactance path to the amplified AC signal. If this capacitor is not present, or in the absence of this capacitor, what will happen is the voltage developed across RE will feed back to the input side, thereby reducing the output voltage. So if this capacitor CE is not connected at the output side, that is in parallel with RE, so whatever voltage that is developed across RE will again go in feedback to the input side. So as a result, what will happen? Whatever output voltage was present, it will be reduced. Okay. So in presence of CE, the amplified AC will pass through the particular stage. Okay. So if CE is not connected, then the amount of the output voltage will be reduced. So indirectly we can say that to offer a low reactance path to the amplified signal, we are connecting the bypass capacitor CE across the resistor RE. Okay. Then what is coupling capacitor? Third thing we have seen is coupling capacitor CC. As we have seen already, it is connected to a main intention of using coupling capacitor CC is to connect different stages of the amplifiers. So the capacitor CC is a coupling capacitor. It connects two stages and it also prevents DC interference between the stages. Okay, so it is not only to connect the AC signal from one stage to other stage, it also prevents the DC interference between the stages, and it is also used to control the operating point from shifting. Okay, so this, by making use of this coupling capacitor CC, we can also see that the operating point will not be shifted. Okay, so this is also called as blocking capacitor because it does not allow the DC voltage to pass through it. So the coupling capacitor CC is also called as blocking capacitor. Why you are calling it as blocking capacitor? Because it is not allowing the DC voltage to pass through it. So in absence of this capacitor, RC will become in parallel with the resistance R1 of the biasing network. So RC and CC. Okay. So in absence of this capacitor, RC will come in parallel with resistance R1, okay, of the biasing network of the next stage, and thereby changing the biasing conditions of the next stage. So if we can just look at the figure once, see here. Yeah. If you are not using this coupling capacitor, what will happen? This RC will come in parallel with R1. Okay, RC will come in parallel with R1. If RC is coming in parallel with R1, again it is going to change the biasing conditions of this next stage. Okay, so not only to connect the AC signal from output of one stage to the input of the next stage, but also to block the DC. Okay, and in addition to that, if you are not connecting CC, what will happen is this RC of the stage will be in parallel with R1 of the next stage. So as a result, if RC is parallel with R1, what will happen? Again, the biasing conditions of this transistor will change. Okay. So that is the reason why you are making use of coupling capacitor. So in the absence of this capacitor, RC will come in parallel with resistance R1 of the biasing network of the next stage and thereby changing the biasing conditions of the next stage. So these are the different uses for which you are making use of coupling capacitors. We'll just have a quick review. Okay. So different coupling scheme, before studying about different coupling schemes, a multi-stage amplifier, it is an amplifier in which more than one amplifier stages are used, or you can say that it contains more than one stage of amplification. Okay, that is called as multi-stage transistor amplifier. Now, how you are going to connect different stages of the amplifier? Okay, output of one stage is connected to the input of the next stage by making use of a coupling device. Okay, so this process of joining the amplifier stages using a coupling device is called as cascading. And then if you see a two-stage amplifier in which you are having a coupling device, okay, so the overall gain of the amplifier will be nothing but product of the individual gains. Similarly, if it is n-stage amplifier, you will have AV equal to product of all the individual gains, AV1, AV2, so on up to AVN. And then why you are making use of coupling? Mostly to transfer the AC output of one stage to input of next stage, and also to isolate the DC conditions of one stage from the next stage. Okay. And different types of coupling. As I told, 3 types of coupling: RC coupling, transformer coupling, and direct coupling. So according to the type of coupling used, you are naming the multi-stage amplifiers. If you are making use of RC coupling, then you are calling it as RC couple. If it is coupling is done by making use of a transformer, it is transformer coupled amplifier. And if the coupling is done directly without any coupling device, if you are directly connecting, then you are calling it as direct coupled amplifier. In RC coupling, what is the coupling device that you are going to use? Simply a combination of RC and CC. RC and CC. And in transformer coupling, we make use of a transformer. Here you don't need any capacitor also. Okay. The second, there is no need of a capacitor here because the transformer itself will convey the AC component directly to the base of second stage. And the last one is direct coupling, as I told. And direct coupling, you'll just connect the output of one stage directly to the input of the second stage. You're not going to use any coupling device. This is mostly used when the load is connected in series with the output terminal of active circuit element. Best examples I can give is headphones, loudspeakers, and so on. And finally, you have a role of capacitors. We have seen, other than coupling, few capacitors are used for different purposes. First thing, if you see the input capacitor CN, yes, it is used to connect the input AC signal to the first stage. Okay, input AC signal to the first stage, input of the first stage. And if you are not using this, what will happen? The voltage source will come in parallel with the resistance R2 of the biasing circuit. So on the whole, the biasing conditions of the first stage will change. Okay. And the next one is emitter bypass capacitance CE. CE is connected in parallel to the emitter resistance RE. Why you are connecting this? Actually to offer the low reactance path to the amplified AC signal. If you are not connecting CE, what will happen? Part of the output signal, whatever is present, it is again fed back to the input side. So what the amplified output voltage will be reduced. So to overcome this problem, we'll connect CE in parallel with RE so that it is offering low reactance path and thereby it will produce a high output voltage. And finally, coupling capacitor CC, it is used to connect one stage to the other stage. And moreover, if you are not connecting coupling capacitor CC, what will happen? The RC of the resistance RC of the particular stage will be in parallel with resistance R1. That is, if you are not using coupling capacitor CC between stage 1 and stage 2, RC of stage 1 will come in parallel with R1 of the second stage. RC of first stage will be in parallel with R1 of the second stage. So on as a result, what will happen is again the biasing conditions of the next stage will change. So to overcome this problem, we'll make use of the coupling capacitor. There is one more use of the coupling capacitor is this one. Okay. So this is about the role of capacitors in amplifiers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.